In this video, we'll be finding the exact values using radians. In this case here, cosine 11 pi on 6. So we shouldn't have to convert into degrees, but you can if you like. What I prefer to do is this. You go, okay, draw out your unit circle, and you go, where is cosine 11 pi on 6 equal to? So you want to find the reference case, the reference angle case, or the acute angle case. So you need to find where cosine 11 pi on 6 becomes an acute angle. So let's draw out 11 pi on 6. Well, firstly, let's do our denominator, and I'm just going to highlight this in yellow. This is base 6, right? Now, normally, we have written here, this is going to be 0, this is going to be 2 pi, right? And over here, this is going to be pi. Now, instead of writing that, let's write that in terms of our base 6. So if this is going to be out of 6, I need to times the top also by 6. So this will be 6 pi and 6. It may seem useless, but it makes life a bit easier. Over here, instead of 2 pi, we're going to make the base 6, so we have to times the top by 6 as well. So this would be 12 pi and 6. Let's draw 11 pi and 6, where we can see this is 1 pi on 6 away from here. And we know this bit here, just for our reference, is going to be 9 pi on 6. So therefore, we are going to just draw an 11 pi and 6 here. Okay, so if this is 11 pi and 6, and I'll draw this all the way around. Okay, that's 11 pi on 6. If that's 11 pi and 6, we always go, okay, what's the angle in between our ray and the nearest x-axis? So our nearest x-axis in this case is the positive x-axis, sorry. So this angle here, we're at 11 pi on 6 here, and we need to add one more pi on 6 to make it 12 pi on 6. Therefore, the angle in here is going to be pi on 6. Okay, so we've done all the hard work. Now we just need to plug it all in. This is going to be cosine pi on 6. Now, cosine 11 pi on 6, is this positive or negative here? It is positive, and therefore we already know here that at the same value is going to pop out because this quadrant is also positive for cosine. Therefore, we can keep the signs the same. And let's evaluate. Well, we know that cosine pi on 6 will be equal to root 3 on 2. And there's our answer. On to sine 3 pi on 4. Next, our first step, draw the unit circle. Do that. Okay, 3 pi on 4. Well, this is going to be 0. This is going to be, and instead of pi, we're going to write 4 pi on 4 because we want to match those denominators. Okay, now 3 pi on 4. Well, this originally is pi on 2, right? This is now going to go to, and let me just wait for that to load. The 90-degree angle is not going to go pi on 2 on, it's not going to be pi on 2 anymore. It's going to be 2 pi on 4, right? We're timesing top and bottom by 2. So where does 3 pi and 4 fit in? It fits in just there. Okay, I draw my angle like that. So this is going to be 3 pi on 4, okay? And that was not neatly done. I might just write it on the point there, actually. 3 pi on 4. Now, as with everything, we need to work out the angle to the nearest x-axis. In this case, it is this x-axis, and that's going to be a pi on 4. And now we can draw our reference angle. That there is going to be pi on 4. So sine, we can see this is the same distance here. Okay, so we can say straight up, this is equal to sine pi on 4. Question is it positive or negative? Well, here sine's positive and over here sine's positive, so we don't need to change anything. So let's just figure out the exact value. Sine pi on 4 is the same as sine 45 degrees. Sine pi on 4 is going to be root 2 on 2. That should be instinctual though. Okay, our next one, we need to work out negative tan 2 pi on 3. Draw out your unit circle. Okay, and we're going to go 2 pi on 3. So we need to match the base there. Okay, and instead of writing pi, I'm going to write 3 pi on 3. And we know up here it's normally pi on 2, right? And that one's a little bit trickier to write, so you can write it as 1.5 pi on 3. Okay, something like that. Now, 2 pi on 3 is going to go here. Something like that. And this bit here is 2 pi on 3. Our next step is to find the distance between this ray and our nearest x-axis, which in this case is here. 2 pi and 3 plus something equals 3 pi and 3. We can see the angle here would have to be pi on 3. Now we can draw a reference angle in our acute or quadrant 1 section, pi on 3. So off we go. Negative tan 2 pi and 3. So let's just ignore the negative bit at the moment and just look at the tan 2 pi and 3. We can write it out as tan pi on 3. So we've done that bit there. And we know that tangent here is negative because it's a negative gradient, and here it's positive. So we're going to have to write this as negative tan pi on 3, right? And all we've done, though, is we've only figured out this chunk here. Then we need to make it negative because there's that negative there as well. So negative or negative is a positive, so therefore we just have tan pi on 3. And let's assess that now. We know that's tan 60 degrees, which is going to be root 3. There's our answer. Our very last one, D, we are going to do the same process. We draw out our unit circle, and our base is 4. So let's make this bit here 4 pi on 4, and then it goes to 8 pi on 4. As we can see, it must do, oh, it's still loading up, but this is going to be 4 pi on 4 here. It goes another revolution, it goes a revolution, 8 pi on 4. We can see here it's gone further. So we have to go around again, which I'm going to show in, let's choose blue. So it goes around again, it goes another 4 pi on 4, so it becomes 12 pi on 4. Aha, so we're nearly there. Let's draw this in green, or let's draw it in black actually. So we can see here that it's gone to 13 pi on 4. So let's draw that out. Like that, doesn't have to be too accurate. This is 13 pi on 4 here. And if you want to think about it, it's sort of gone 1 and then 2, sort of like that. Almost looks like an escargot or a snail or something like that. So it's rotated around 13 pi and 4, so it's done one revolution and then another 5 pi and 4 revolution. So let's find that reference angle. We don't care how many revolutions it's done. All we care about is the distance between that ray and that x-axis. In this case here, this is 12 pi on 4, this is 13 pi on 4. The distance is pi on 4. Now we need to find the reference, so we know it's now pi on 4, so we can write that out. It's equal to cosine pi on 4. Our next step is to determine whether it's positive or negative. Well, over here it's negative, and this is always positive. So if we have cosine pi on 4, it needs to go negative. To change it to negative, we put a negative there. Now let's assess. Negative cosine pi on 4 is negative root 2 on 2, and there's our final answer. Now we can actually check and confirm our answers using our calculator. So if you do want to check this yourself, you can. So off we go. Make sure you're in radians. You can go shift 2 for cosine, and then go shift 0 to get the fraction, and then just type in these to confirm. So let's go 11 shift 0 for pi on 6, and then close the bracket. And make sure you're going to go in standard because all of these are going to be exact value questions. So here we go, root 3 on 2. And you can use this manner to confirm all your answers. Hope you enjoy the video. Cheers.